Does malloc allocate garbage values? Does calloc allocate multiple blocks? Most students get this wrong. Let's fix this today. Hello everyone, welcome back to OneShot Coding. In this video, we are going to clearly understand dynamic memory allocation in C. We will cover the four most important functions: malloc, calloc, realloc, free function. We will understand what they do, their syntax, code examples, and finally the difference between malloc and calloc. Let's start with malloc function. Malloc stands for memory allocation. It is used to allocate memory dynamically at runtime from the heap. The malloc function in C returns a void pointer. This pointer points to the first byte of newly allocated block of memory on the heap. If the allocation succeeds, it returns a pointer to the allocated memory. The memory is suitably aligned for any object type. If the function fails to allocate the memory, it returns a null pointer. Now, we know that it will return a void pointer. So, because it returns a void pointer, it can be implicitly assigned to any pointer type in C. Let's see via the example. Let's see first the syntax of malloc. So, if we want to allocate memory using malloc, we write pointer equals to type star malloc size in bytes. So, you will see the example code here. We are creating a pointer integer star ptr. Now, we are following the same above syntax here. We are writing ptr equals to integer star malloc 4 into size of integer. Let's see here what happens. Here, this is our number of elements. Here, size of integer. We know that this integer contains 4 bytes of memory. So, size of integer will give us 4. And 4 into 4 becomes 16. So, the memory will be allocated for 16 bytes. So, if we run this code, a memory will be allocated for 16 bytes like this. And in this memory location, now we can store 4 elements. So, if I want to store some numbers, I can store here 10, 20, 30, 40 in this memory location. And my ptr pointer will point to the first byte of the memory location. Let's assume the first byte of the memory location is 1000. So 1000 is the address. So my ptr will contain the 1000 address. Here sometimes it is possible that the memory will not be allocated. So if the memory will not be allocated, our pointer will contain null because it returns null if allocation fails. And here I said that our memory contains garbage values. So initially, once we allocate the memory and we do not assign any values, our memory will contain garbage values. So it will contain some random data. I'm just giving some question mark here. So we will understand that it will contain some garbage values. What are garbage values? This is some random data our compiler assigns. Some random value or random data our compiler will assign to these memory locations. Let's now write the code of this malloc function. We will write the code, we will allocate the memory and we will print the values. Let's quickly go to the code editor. Here, now let's start our malloc code. So first let's create a pointer integer star ptr. You will write ptr equals to typecasting integer star malloc 4 into size of integer. So in this line we are allocating memory for 4 elements. Now we want to enter some data in this element. So we can assign directly data here also, like ptr at 0 equals to 10. Some value you want to insert, ptr at 1 equals 20. Or if we want, we can assign values using for loop also. How we can assign? We will write a for loop I equals 0, I is less than 4, I plus plus. Here we will take directly input scanf %d, comma, address of PTR at I. So I am writing a for loop. This loop will run 4 times, and the input we will pass, all the inputs will be inserted at the created memory location. Now we want to print all the values. So let me give some comments here. Also we are printing. So to print also we can write the same for loop, I equals 0. I is less than n. Here we are not taking n, so we will give directly the size I plus plus, and we will write printf instead of scanf. So I am writing printf %d, comma, PTR at I. In the last, we use a function free. In free, we pass the PTR, and in the last, we write return 0. Now let's again see the code what we have written here. So here, let me give the comment. Here we are taking inputs. Okay. But first of all, we created a pointer. Second line, we are allocating memory using this pointer. We know that this function will return as a void pointer. So we can typecast it into a type of our pointer. So my pointer is of integer type. So in this line, we are typecasting our void pointer into integer type. After this, we write the malloc function, and inside the malloc function, we are giving the size. So 4 into size of integer. Size of integer is going to return as 4, and then 4 into 4 is 16. So a memory will be allocated for 16 bytes. Now in this memory, I can take some inputs. So here I have written a for loop. We are starting from 0. We are running it 4 times. So we are taking input at PTR at I. So my first time for loop will run for I equals 0. We will take input at PTR at 0. So we will pass the first element that will be inserted at the 0 position, and then this I plus plus I will become 1, and we will take input at PTR at 1. Then I plus plus I will become 2. Then we will take input at PTR at 2. Then I plus plus I will become 3. Then we will take input at PTR at 3. Then I plus plus I will become 4. Our condition will be wrong, and the for loop will terminate. After this, we have written the same for loop to print all the values. You will see one difference here is while taking the input, we are passing the address of PTR at 0, PTR at 1, 2, 3, 4. And while printing, we are just writing PTR at I. In the last, we are writing a function free PTR. So what this function do? So once if we allocate memory using malloc or calloc, our memory remains there until and unless we ourselves clear this memory. To clear this memory, we have a function called free. In this function, we pass the pointer name. So it goes to the same memory location, and whatever data is saved there and the memory location we allocated, it clears that out. It returns back the memory to the system. Now let's quickly run this code, and we will move to our next point. So let me quickly run this code. So here, let me move the terminal on the top. Okay, my terminal is little bit slower. Let me again open the terminal. Okay, now let's write gcc pointer.c./a.exe. I will run this code. Now it is asking us to give the input. Memory has been allocated for 4 size. Now we can pass 4 inputs. I will pass 10, 20, 30 and 40. Now if I press enter, now this print for loop will run, and it will print all the values. So let's press enter here. You can see 10, 20, 30 and 40 has been printed. So this is how we are going to allocate memory using our first function malloc. Let's get back to our PPT here. So malloc will allocate a single block of memory. Always remember. Okay. It will allocate single contiguous block of memory. In this memory location, we can insert some elements. Now, same like malloc, we have another function called calloc. Let's see what is calloc. Let me move to the next slide. Calloc. Calloc stands for contiguous allocation. Calloc allocates a single contiguous block of memory and initialize all bytes to 0. So, you will see here is both our malloc function and calloc function allocates single contiguous block of memory. The difference here is, here in calloc it initialize our memory location with 0, while in malloc function it initialize our memory location with garbage data. There garbage data is there. Okay, so if we allocate the memory, we immediately needs to assign some values in the memory location. But here it initializes our memory location with 0. So some points I have written here is it allocates single contiguous block of memory, then initializes memory with 0 and returns a void pointer. Both the calloc function and malloc function will return a void pointer. Here, let's see the syntax. Here we are writing pointer equals to type star. This is nothing but type casting. Because it returns a void pointer, so we will implicitly typecast into the type of pointer. Then we are writing the function name calloc. Here we'll pass two things, number of elements. So if we want to insert 4 elements, we'll pass 4 here, comma size of each element. So if I want to insert the integer values, I will pass size of integer. So this is the syntax of our calloc function. Now below here you can see I have written the code. We are creating an integer star ptr pointer. Now in this pointer I am writing the code of calloc function. So what we are writing, pointer equals to integer star calloc 4 comma size of integer. So here again memory will be allocated, contiguous memory will be allocated, same like the above. Okay, so if I am writing this, a contiguous memory will be allocated. One sec please. Our contiguous memory will be allocated for 4 elements. In this we can assign 4 values. So my pointer, this is my pointer will be pointing to this memory location which we allocated using this calloc function. Here I can pass some values 10, 20, 30, 40, and it will suppose the address of the first byte is 1000. So my pointer will contain this address. This is about our calloc contiguous allocation. The difference here is initially our calloc function will contain 0. So if we do not give any data here, if we do not assign any values, my calloc, if we allocate the memory using calloc, it will contain 0. While in case of malloc, it will contain what? It contains garbage data. Some garbage data means some random data. But in calloc function, it contains 0. This is the major difference between our calloc function and malloc function. Now let's quickly write the same code for calloc function. How we will allocate memory using calloc function. So I will just update the same code for calloc function as well. Here what we will do is, instead of writing malloc, we will update with this calloc function. And we know the syntax here is 4 size comma. So I am writing 4 comma size of integer. I will again show you the syntax. Here we are writing number of elements comma size of each element. So number of elements, suppose I want to insert 4 elements. So 4 comma size of integer. Now how we will take input? Same code. We will write the same for loop. We can run it 4 times and we can take input at each position. Then for printing also this code will remain same. In the last here also, because we have allocated the memory using dynamic memory allocation. So in dynamic memory allocation, we know that we need to free the memory ourselves. That's why in the last we will always write free function. In this free, we will pass the pointer name. So now let me again run the code quickly. So let's write the command gcc pointer.c /a.exe. Now here we can pass again 4 values. I am giving 100, 200, 300 and 400. Once I press enter, you can see all the values have been printed. So the memory has been allocated. After this, we inserted the values in each memory location and then our data has been printed. So this is our calloc function. So if we go via this diagram, so here we have inserted what? 100. Here we inserted 100. Here we inserted 200. Here we inserted 300. Here we inserted 400. And then we printed all the values. So this is about our calloc function. So we should understand what is the difference between calloc and malloc and where we will use calloc and malloc function. Now let me come down. I will show you the difference between malloc and calloc, because we know that both are used to allocate a single block of memory. My malloc function and calloc function both will allocate a single contiguous block of memory. Then why are we using both functions? Because they will not differ in memory layout. They will differ in initialization. Just as I explained you above. Malloc takes, first difference is our malloc function will take total bytes, and here the memory will contain garbage values. I have written a code also of here malloc function. If we allocate memory using malloc function for 4 elements, and if we allocate memory using calloc function for 4 elements, you can see the diagram here. This is the diagram for malloc function and this is the diagram for calloc function. So our malloc function contains garbage values. You can see question mark I have written for garbage values, while our calloc function contains 0 initially. So I have written here that calloc takes elements plus size and the memory will be initialized with 0. It will contain all zeros. Okay. Here there are a few more differences I want to show you. The first difference is of initialization. So in initialization, we know that malloc contains raw allocation, so it contains garbage values, while calloc is called clean allocation because it initializes with 0. Now why does this matter? Like why are we storing garbage values? Why we are having garbage values in malloc function while we are having 0 in calloc function? Why does this matter? This matters because garbage values can be dangerous in many scenarios. I will show you the first scenario. Let's create a counter variable. Okay, we want to create a counter variable. We will write the code of our counter variable and we'll see how it can be dangerous. So let me comment this code here, or let's remove all this code and we will write the code for our counter. Let me give the comment also, counter. So for this counter, I am going to create a pointer integer star counter equals to, and now we are going to allocate the memory first using malloc function, integer star malloc. I want to give 20 element size, so I am passing 20 into size of integer. Fine. So this is the syntax of our malloc function. Memory will be allocated for 20 elements. Here I have written, I want to write counter. Okay. Now I want to counter at 0 plus plus, because each time we would like to increment our counter. So I am writing counter at 0 plus plus. So whatever the value at 0, I want to increment it with 1. That should be 1. Now let's print this value. %d, comma, counter at 0. Sorry, here counter at 0. And in the last we always pass free ptr and return 0. Here we don't have any ptr. Our pointer name is counter, so we need to pass counter here. We are done. Let's run this code. So I'm running this code. Let's see the output ways. Now let's see the output. We are getting some address, right? Because we know that malloc, if we are using malloc function, it will allocate the memory, and my memory will contain some random data, some garbage data or some random data. So it is containing some garbage data. Then we are saying counter at 0 plus plus. So we are incrementing the memory address, not the values, right? So in this case, it can fail, right? It will give us some undefined behavior. It will not work out. So here we have to use calloc function. Now if we use calloc function for the same operation, so I will update the same code for calloc, but we know that in calloc we write the code, our code should be comma. We need to pass 20 comma size of integer, and I am doing the same thing, counter at 0 plus plus, counter, we are printing counter at 0, but here I would like to print before also. Before incrementing the counter at 0 position, I would like to print counter, and after incrementing also, I would like to print the counter. Let's see what is the output. I am giving a space. Now let's see the output. Let me clear this. Now we are writing again gcc pointer dot c dot slash a dot exe. Now you see the output. Here at the first position, we are getting the output 0. Why? Because we know that calloc allocates our memory and initially it contains 0, right? And the moment I do counter at 0 plus plus and again I print this, we'll see the output, we are getting 1. So our counter is working perfectly with calloc, while in malloc function, it was giving us some random data, right? So we cannot perform this operation using malloc function. So these are some scenarios where we will choose which function we need to use. Either we will be using our calloc function or we will use our malloc function. There are some other scenarios also. Let's take the second case. Here it is also used for semantic intent. Now some of the good C programmers use them to express intent also. We know that our malloc function says, give me memory, I will manage contents. So if we are allocating memory using malloc, it says that give me memory, I will manage contents. But here we immediately need to overwrite memory, and it is used in buffers or arrays filled right away. So if we are creating an array that needs to be filled right away, then we will go with malloc function. Now with calloc function, it says that give me memory that starts clean, means that it is initialized. Okay, it is used when we rely on default 0 values, or we want to create array of counters or flags. Then we will go with calloc function. I hope that the malloc and calloc functions are clear with you all. Now let's move to our third function, that is realloc. Realloc stands for reallocation of memory. It is a dynamic memory management function used to change the size of an already allocated memory block during program execution. It resizes previously allocated memory to new location, and it returns pointer to the resized memory. It will return null if allocation fails, same like the above two functions. So here, suppose we have allocated memory using any of the function malloc or calloc, and we inserted some data. So if we will see the diagram here I have created, so let's assume we allocated memory here for 3 elements and we have inserted 3 data here, 10, 20, 30. After some time, we want to insert few more data. So we have an option to reallocate memory. Here we can increase the memory size also or reduce the memory size also. So now I want to insert 2 more elements. I can use the realloc function. Here let's see first the syntax. We will write pointer equals to type star. Type star is again the typecasting. Then here is my realloc function. This is the function name. In this we will pass 2 values. The first one is the pointer. The pointer which is pointing to this location. So this PTR If we have allocated memory location using the PTR, we will pass that PTR here. Then after comma, we will give the new size. So initially, suppose we have given the size 3, so we allocated memory for 3 elements. Now I want to store 5 elements. So we will pass here 5 into size of. We will pass 5 into size of integer. Now the new memory allocation will contain memory for 5 elements, and we can insert 2 more values here because it already contains 3 values. In this current memory, we have already given 3 values. So now I can insert 2 more values in the new memory. And this memory will be allocated same in heap memory. Now let's write the code of realloc function, and we will understand by writing the code how we will allocate memory. Let me remove this code. Now let's again create a pointer first. So I'm creating a integer star ptr. Now I want to insert 3 elements. I will write pointer equals to integer star. So integer star is our typecasting. Then I'm using malloc function. In this function, we are passing 3 into size of integer. So a memory will be allocated for 3 elements. Now in this memory, I want to insert the values. Let's assign the values. So we will write pointer at 0 equals to 10. We can directly assign values like this also, as I told you above. Now I am writing pointer at 1 equals to 20, pointer at 2 equals to 30, and we are done. Now I want to insert 3 more elements in the memory. In the same memory location, we want to insert 3 more elements. Now what we can do is, we can use our realloc function. So we will write pointer equals to typecasting. So integer star, my function name is realloc. We'll write realloc. Here we can pass 2 things, my pointer name. So first we'll pass ptr, then this new size. So now I want to add 3 more elements, and we already allocated memory for 3 elements. Now we will give the new size as 6. So I will write 6 into size of integer. So now our new memory will be allocated for 6 elements. And after this, now I can assign values in this new memory location. So in the 0, first and second memory location, we have already inserted the data, so it already contains the values. So now I will assign values after this position. So I am writing ptr at 3 equals to 40, ptr at 4 equals to 50, ptr at 5 equals to 60. And in the last, now we will print all the values. To print all the values, we know we can write a for loop. I will run it 6 times. ptr integer I equals 0, I is less than 6, I plus plus, and we'll write printf %d space comma etr at I. So this loop will it will print all the values. After this, we know that we free our memory. So we will write free ptr, and in the last we always write return 0, and we are done. Now let's run this code. So what will happen here is, because we have directly assigned the values, so initially memory will be allocated for 3 elements, and then 10, 20 and 30 will be assigned to these memory locations. After this, the memory will be reallocated. A new memory, this memory will be reallocated with 6 size of 6 elements. After this, the new values will be assigned to the new memory location, and in the last, we are printing all the values using our for loop. So all the values will be printed. Let's quickly run this code and let's see the output. So I will write gcc pointer.c.a.exe. Now you can see the output. We are getting 10, 20, 30, 40, 50 and 60. So this is about our realloc function. After this, let's see why do we need reallocation. Because in real programs, memory requirements are often not known in advance. Let's see some real world examples. So you see that in dynamic arrays, if we want to create dynamic arrays like array list, we need to use our realloc function to reallocate the memory. If we are creating a list of students and that list keeps growing, then we cannot rely on some fixed size, right? We need to reallocate memory, means we need to increase the memory size. So there we can have the need of our realloc function. If we are reading some file where the size is unknown, then what will happen, that we have allocated memory and we are reading some file. Now that file can be of larger size compared to the size we have given to our variables or arrays. Then there also we need to realloc our memory. So we need to increase the memory size. So there also we can use our realloc function. And at the last, we can use an input buffer also. If the input buffer is expanding, there also we can use our realloc function. So at these places, we can use our realloc function to reallocate memory. Again, I will say in the realloc function, I can increase our memory size also and shrink our memory size also. Both tasks can be performed in realloc function. Now, free is called free allocated memory. So you will see here I have written some points. Free allocated memory. Free releases the dynamically allocated memory back to the heap, making it available for future allocations and preventing memory leaks. Pointer becomes invalid after deallocation. Dynamic memory is not released automatically. We must use free function to return memory back to the system. It prevents our memory leaks. So if we allocate memory using dynamic memory allocation, that memory doesn't get freed automatically like a static memory allocation. Here we need to free the memory and we need to return it back to the system using the free function. That's why we use our function free. In this function we pass the pointer name you use to allocate the memory. Okay, so that's all for today.